Okay, thank you, Matthew. I hope everybody can hear me.
Yeah,
And
loud and clear.
good afternoon and a warm welcome from Düsseldorf. My name is Heinz-Josef Ponten from PSI Metals. And I'm very happy today that PSI Metals is presenting today's Green Steel Making webinar. And as you said, in my role as product manager for steel making, we call that liquid. And for energy, I want to discuss with you efficient scheduling considering energy limitations and availability. We all heard about that already in the previous presentation. Energy will be one topic, and I want to move the focus a bit towards digitalization in my presentation. And here I'm repeating what was said already. So before going to the details, I want to start with the facts, and it's not surprising, well known for everybody here around. And depending on which statistics you read, you will find different figures, whether it's 7 or 8% of the world's industrial greenhouse gas pollution. But at least it is recognized as a key and hard to abate industry. And the world is looking for rapid, but also for innovative transformation. And there's also no doubt, and I guess everyone shares my view here, we all need steel. Steel is a core pillar of our modern society. It is the high-tech engineering material to build our future mobility, climate neutral buildings. And it's absolutely necessary for building the infrastructure for sustainable energy. So steel is vivid, it makes the world tick. These are the facts, but as we heard already, we have a lot of challenges ahead of us. The carbon neutral steel production shall be achieved latest by 2050. And our customers have set up huge transformation programs to achieve major reductions already by 2030 or by 2040. And despite this evident process, it's a long and challenging way. The end customers, they are asking already more and more for CO2 reduced products. The new processes using hydrogen, green hydrogen, DRI, with smelters, they will replace the classical blast furnace and BOF routes. Other steelmakers, they are changing completely to electric arc furnace route, or what we heard, we are going to combine all these new technologies. Therefore, there's a massive demand for hydrogen and electrical energy to power all these new processes. However, the transformation process will need time. New green hydrogen and DI-based technologies and steelmaking routes will operate in parallel to the classical routes. It's not a big bang. It is a stepwise replacement, and the hybrid steel plants, we call that the hybrid steel plants, that will be the solution for the coming decades. And in the last year, instigated by the geopolitical situation and Ukraine war, we all have been blindsided by drastically rising and fluctuating prices for energy. That means energy and its availability has to be managed more than ever. And in my presentation, I want to discuss how PSI Metals can support, on the one hand, the digitalization, but also the transformation to green steel making. And that's the core topic of this presentation. How do we efficiently schedule and consider energy limitations and the availability of energy? I want to share with you the PSI Metals view on how steel plant digitalization can become future ready to cope with all these challenges ahead of us. Let me start with this figure here. On the left scale pan, you see the classical optimization goals like throughput, due date, lean stocks, as well as quality, which are always used in planning and scheduling algorithms to efficiently optimize the production chain. On the right pan, we see the green ones. We see energy usage and price. We see energy availability and volatility. And of course, we see the CO2 emission during the production processes. We call them the green KPIs. And these are so-called sister or counter KPIs to the classical ones. And these ones need to be managed, they need to be balanced, and they need to be optimized in the one and in the other direction. I would like to introduce now our online heat scheduler. We see here a typical Gantt chart showing the schedule for a rather complex steel plant with BOFs, but also with an EAF, secondary metallurgy, and casters. The online heat scheduler generates the detailed routes and calculates exact time schedules for all the heats in the given time horizon based on steel grades, line availability, and production times. But that's not all. The scheduler also generates forecasts for so-called secondary resources, which could be material like hot metal. But much more interesting for the future is to model and forecast other resources like electrical energy, DRI, or even hydrogen. Based on the availability of these resources, we are able now to schedule and optimize different scenarios. This is quite useful and important for the hybrid steel plant scenarios, in particular in the transition phase, where we will have BOFs operated in parallel with electric arc furnaces and different smelters. This leads me to the next slide, where we can have a closer look. Again, we see the Gantt chart with our what we call the hybrid steel plants. We have 3 BOFs here and 1 EAF, and the red line, it should indicate that, for example, last BOF number 1 is currently not in operation because we have an EAF in operation in order to replace 1 BOF. And in the lower part of the chart, we see 2 forecasts. We have what we call the hot metal stock evolution, the hot metal which is needed in the BOF processes, but we also have a forecast for the electrical energy demand of the electric arc furnace and the ladle furnaces. The energy demand forecast is based on menus, scrap menus for the electric arc furnace, and for the ladle furnace based on temperature increases. This forecast, they can be handed over to energy management systems or even to the energy provider to automatically align the demand and what needs to be provided. This is a very important information for the energy supplier in the future, as these steel plants, they will be mega consumer of electrical energy. And for the complex hybrid steel plants, we are able to adapt the same concepts also to forecast hydrogen or to forecast DRI demand. And finding the right answer on how to run such a plant in the most efficient way becomes a more and more complex task for the schedulers and the users. On this slide, I want to show how the user is supported in this complex task. The integrated dashboard, it helps the user to manage and evaluate different scenarios. That means the tool calculates and optimizes different scenarios with these different KPI settings, and the user needs to decide for the best one before releasing new schedules to the production. In the middle here, we call that a chessboard. It shows how different KPI pairs fit to each other. For example, the number of ladles in use versus the caster utilization. The greener, the better the fit is. On the right here, we have a slider where we can set priorities for different optimization goals. A goal function for the optimizer could be the number of ladles in circulation. And here in the spider, it shows us nicely the KPI fulfillment within the different scenarios which have been calculated. And last but not least, there's one configuration slide where we have some sliders where you can set and define priorities, how to automatically decide for the best calculated scenario before releasing it to the production. The simulation of scenarios can be done in parallel to the normal operation, which means while the online heat scheduler is tracking and scheduling the current heats and treatments in the plant, the user can simulate scenarios, other scenarios. This makes sense in case there are actual delays or disturbances in the plant, or for instances, new heats have been introduced, new schedules have been introduced, or heats need to be regraded. I want to move the focus away from steam making to downstream production. We see what we call an order scheduler, and this tool is used for short-term, medium, and long-term cross-plant scheduling of the entire order book. It optimizes the bottleneck lines, it synchronizes the lines across the entire production chain, and it monitors the progress and performance of production orders. And in the next screen, we basically see the same what I've explained before for steam making. In the upper part, we have again the Gantt chart with the schedule for the different lines. In this example, hot rolling, pickling, cold rolling, tandem, and continuous annealing lines. And in the lower, the bar chart, we see again a demand forecast for electrical energy. To calculate this forecast, we maintain master data for transition, transformation energies, and rules how to calculate the different energy demands for the materials which are processed, which are rolled in the different lines. But as you can see, we also have some red lines here, which are on top of the bars. The red lines, they are indicating energy limitations during different periods of the day. And we also see that the schedule is not fully aligned with the energy limitations. We see that we have here material and rolling programs which might use more, or which are not only might, which use more energy, which is available at that moment. And that could lead, in the worst case, that lines need to be stopped or penalty payments have to be done to the energy supplier. And these situations need to be avoided. Therefore, this order scheduler has a freedom by running different optimization algorithms to move orders with higher or lower energy demand to the right place. And this is done, of course, while considering other restrictions, for example, allowed width or thickness jumps, but also, of course, the due date. And in this slide, you see that the schedules have nicely been rearranged to adhere to the limitations, and production orders and material with lower energy demands have been moved into the time zones where we have limitations, and the ones with higher demand, they have been moved where we don't have any limitations anymore. What you see here, I call that the green KPI-driven schedule optimization cycle. And I want to express that planning, scheduling, efficient optimization of production, energy forecast and management, and alignment of the production to energy demands and availability are not isolated functionalities. They are influencing each other. They need to collaborate in a cycle in one system to find the best solution for a given scenario and production situation in the plant. And now I want to go one step further, away from the daily business of planning and scheduling to energy procurement. This slide shows a quite simplified version on how energy mixes are composed. We have the quotas which are purchased long term, that could be 1 or even 2 years upfront to secure and guarantee price stability. We have medium term quotas which are purchased a year or month upfront. We have short-term quotas which are bought on the spot market, and as we have heard before, we also have own production of energy, of electrical energy on the sites. In the graph below, and this is an example for Germany, but it might also be valid for Europe as a whole, we see the evolution of the four so-called forward market prices of the last 15 years. And what we can see that for many, many years, the yearly future prices were very stable. But in the last 2 years, due to Corona, due to geopolitical situation, it changed tremendously. We had steep increases due to Ukraine war. Everybody became nervous. Meanwhile, it went down again and stabilized. Oops. Unfortunately, no one knows how this would be in future. We believe that we will never go back to the price levels where we were before. The reality is that we need an enormous amount of electricity, green electricity, alternative electricity, to drive the green transformation in all industries, not only in steel. Prices, therefore, will stay high in future, but we have also seen a heavy volatility on the prices. Availability and volatility of wind and solar power will be another aspect to be considered in the green transformation. And we certainly believe that this will lead to a different strategy to purchase and manage energy. The logical consequence is that we need to bring production planning and scheduling with energy procurement closer together. And I don't mean that we only need to bring the production people and the energy managers together on a round table. I assume that's hopefully already happening today. I say we need to link their processes closer. And by linking, I mean to digitalize the entire process of planning and purchasing for different horizons and to put them together in one system. It leads me to, I call that is the PSI Metals vision. Scheduling combined with energy trading powered by Quality AI. With this vision, we are bringing the expertise and functionalities of 3 PSI companies together. We have PSI Metals with planning and scheduling functionality. We have PSI Energy Markets with energy trading. And we have the PSI Fuzzy Logic company bringing the smart decision solvers into our products. PSI has now developed a so-called smart day trader algorithm based on Quality AI, and we call that the PSI Algo Trader. The Algo Trader uses the demand forecasts and automatically fills the gaps for certain periods by buying energy quotas on the spot market. This brings real-time production and energy management together to cover the short-term demand on top of the given energy quota to react very fast to changes and energy needs in the production. But it's also able to sell quotas again on the spot market. For example, in the case production does not need the available quota during unplanned stoppages. We have already first pilots running in the industry. And I want to close my presentation now, and I hope I was able to give you an impression of how PSI Metals support the digitalization and transformation of green production management. With PSI Metals, we are creating a holistic 360-degree view on green production management. Classical planning and scheduling services, where cost effectiveness often implies already sustainability, have been enhanced now by energy demand forecast and smart optimization algorithms, which are driven by green KPIs. With this, we want to set a new impulse. coping with the challenges of complex hybrid steel plants and efficiently manage the production, but also energy demands and energy availability. For the transformation journey of our customers towards sustainable and green steel making, and to continuously reduce the CO2 emission, PSI has the right tools to balance and to trade off between economical and ecological production management. Thank you very much for your attention, and I hope I could make you some appetite for a bit more. So don't hesitate to contact me in case you have questions and would like to hear more. Thank you.
Thank you very much, Heinz. Thank you for a great presentation. Does PSI Metals have any have already reference implementations in the steel industry of what we have seen today?
Yes, we have. So for the different areas, so we are doing that for many years already. So planning, scheduling, that is our daily business, and running in steel plants all around the world. And we also have already reference implementation where, and that is in electrical EAF steel plants, where we do the energy demand forecast, where we have the link to the energy supplier to provide whenever the situation in the steel plant changes, the new forecast for the demand on short and medium term, so that the energy provider always knows what needs to be provided. And that was basically done because in Europe we have since ever we have this not let's not say the limitations, but we have contractual situations where steel makers buy a certain energy quota, and they need to adhere to a given quota. This needs to be controlled on this famous 15 minutes intervals, and you are not allowed to exceed these limitations. So forecasting is key, also to have nice contractual situations with the energy supplier to reduce your payments.
Okay, now I've got a question. I'm not actually sure, I'll be honest with you, whether it's for the previous speaker or whether it's for you, Heinz, but I'll read it out. And if it's not you, obviously you'll know. It says, it's from Yasin Bayik, and they say, how long can a project like this be put into use in a facility operating with an EAF with a 150-ton furnace? I'm assuming that might well be for Emmanuel, but you can tell me if that.
Yeah, I think so, that it was for Emmanuel. Yeah.
No problem. Okay, we've got another question here. You were talking about different planning and scheduling tools and horizons. Are these tools used for offline planning and scheduling? Let's say people sitting in the back office, or is it used for real-time operation during production?
Yeah, it's actually it's for both. So it's indeed you plan ahead, and that is basically done by planning, scheduling people sitting in the back office who are doing the scheduling for the next day, for the next shifts. But it's also used in the production, so in real time, and particularly this online heat scheduler. It tracks and controls the operations in real time, reacts on every situation in the steel plant, if there are delays, treatments take longer, shorter, to ensure that heat sequences in steel making always meet the caster, that sequences are not interrupted. And that is what we are bringing together now with energy demand forecasts, availability of energy, to also consider that. But not only for, I was mainly talking about energy, electrical energy. We can also do that. We can adapt the concepts also to forecast DRI demands, like we do for hot metal or even hydrogen or other resources.
Okay. Actually, Yasin has come back, and it is a question for you. He says, how long can a project like this be put into use in a facility operating with an EAF with a 150-ton furnace?
I'm not sure whether I understood the question. How long a
Yeah, he says, I mean for PSI. So it was a question for you, but whether you understand that. or not sure? How long
I
can
mean, how long it takes to implement such a project, or
yeah, that
yeah,
probably could be what he means. How
yeah.
long can a project like this be put into use in a facility?
That so usually it depends. So so let's say a usual project time is 1 year to put that into operation. So there's a specification phase, and the majority of effort is always to link all the systems together, to interface with other systems, to interface with level 2 systems. So our system is part of an MES system, but also can operate as a standalone service. So we need to integrate that, and that takes time, not only for us, but also mainly for the companies who are going to use that. So let's say it can between 7 months and a year, I would say.
Yeah, yeah. And one final question from me, just a general question, really. Wondering how here we are in this world of looking towards the decarbonized steel industry, and obviously everyone's working, 100%, if not more, on this. What's the situation like within PSI? Are you now finding that a lot of the projects you're getting, a lot of the interest being shown in what you do, is related to decarbonisation?
Yes, indeed, it is. But I would also honestly say it's more that our customers are now also starting digitalization processes because the complexity is growing. And indeed, decarbonization is always, and that is also, let's say, an enabler that our customers they have new money to do that. They are investing a lot, and that leads also to the fact that they start to digitalize the processes more, which is also key to have efficient operation, and to control the decarbonization. And yes, indeed, that is what we recognize, and nicely recognize, I would say.
Now, Edgar Adrian has a question for you. He says, does PSI have anything related to scrap management?
Yes, we have. So what we usually do is, and that is, so I was concentrating on one topic today, basically. So we also have scrap optimizations, calculations to calculate the scrap mixes which are used for the different steel grades. And in the same way, like we do the forecast here, we also can do, I call it now, forecasts or calculations or optimizations to calculate the demand for different heats in a row, for a complete sequence of heat, for shift of, or also for medium term. So what we can do is to link the scrap calculation, the scrap demand calculation, also to planning. We know what will be produced, so we know what kind of scrap mixes we need and how much of the different scrap types we need, and that can even be used for purchasing the right scrap types, the right scrap mixes upfront.
Okay.
And of course, scrap yard management, logistics of the scrap yard is also part of our solution.
And one more question from me, the last question, let's say. We have a big conference coming up in September, the Future Steel Forum, and I'm looking at theming it towards the digitalization and decarbonisation. I just wonder, there's someone involved in the digitalization side of the industry. Do you see a strong link between digitalization and decarbonisation of the processes?
Yes, 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 I do, as I said before. So I think efficient decarbonization, and what also needs to be done then is to track. So today the laws are not so consequent that the carbon emission reports, they are not detailed, but customers are asking already today to have a tag on the material piece, whether it's a coil or whatever it is at the end, to see what are the different emissions. And also here, we are going to support that. We were talking about the different scopes, about scope 1, scope 1 production emission and scope 2 due to the energy which has been purchased, we can track that quite exactly and even link it to a particular piece of material. So digitalization is also key for decarbonization in that particular case, and also for the reporting. It's
Okay.
without digitalization, you cannot do a precise reporting of your carbon emission.
Okay. Well, look, thank you very much, Heinz Joseph. That was a very interesting presentation.